Welcome to week 6, Algebra 2. I hope you guys are all doing really well and enjoying sunshine and or rain, depending on the day. Looking forward to us almost being done. We're getting really close to the end of the semester or quarter. So I hope you're staying on top of things. Remember, you can always meet me in a Google Meet or email, call, whatever you need, but make sure you're getting some help and staying on top of this so that you can finish strong. So we're going to look at some more of our sine and cosine functions on the graphs, more transformations. This time we're going to focus on our reflections and horizontal transformations for the most part. We're still going to need our unit circle and graph paper, or you can use the graphs that are attached to the notes. So give yourself a chance to download the notes and we'll get started. So first we have the reminders from last week on the 5 key points that we need for graphing cosine and sine functions. Notice that we are just using our unit circle and focusing on for the cosine, we're going to only use the x coordinates of each point. And that's on the unit circle again. We look at our unit circle, and for the 5 key points, we start at 0, the angle of 0, and look at the x coordinate, which is 1. And then we go to pi over 2 and look at the x coordinate, which is 0. And then we go to pi, our favorite number, and look at the x coordinate, which is -1. And then we go to 3 pi over 2 and look at the x coordinate, which again is back to 0. And then we're back to 2 pi, and the x coordinate goes back to 1. And then we do the same thing for our sine function, but this time we're going to look at the y values. And so we start at 0, and the y value of 0 is 0. And then we go to 90 degrees, or pi over 2, and look at the y value, and we get 1. We go over to pi, look at the y value, which is back to 0. We go to 3 pi over 2, look at the y value, and we get -1. And then we go back to 2 pi, which gets us back to 0. So those are the 5 key points of each sine and cosine, the sinusoid functions that we started looking at last week. And then we have a review of the steps for graphing as well. This was on our previous week's notes. And we're going to continue to follow these steps. In general, we're looking for the amplitude, period, and the vertical shift. We're going to focus on the midline to help us. We're going to graph our key points of the parents, the sine and the cosine function that we just did. And then from there, we're going to translate our key points. So we're going to do a little reviewing of some that we looked at last week. Our first thing we're going to do is focus on the amplitude, and that's the a value, the absolute value of the a value in front of our function. So in this case, our amplitude is 2. And then we look at the period, and that's always 2 pi divided by our b value. And the b value is the number that's multiplied here in front of our x, which is a 1. So 2 pi divided by 1 is still just 2 pi. That gives us the distance, the horizontal distance of one cycle. So we know we're going to end at 2 pi. So our final, the end of our cycle is going to be here at 2 pi. We're going to start at 0, end at 2 pi. So we know that will be the distance of one cycle. And so once we've gotten that, then we also want to check for the midline. that kind of gives us a little guideline. So our midline is always y equals whatever our k value is, and that's the vertical shift up or down. And so in this case, our midline is going to be at -1. So that's telling us that our cosine function is going to be shifted down to -1. So I'm going to go ahead and draw that line in while I have my color going on here. Okay, so those are our first steps. And then we always start with our parent function, which is the cosine of x. And so we just graphed that up above. And the cosine starts up at 1, and then goes to 0, and then down to -1, back to 0, and then finishes at 1. So that's our cosine parent function, and it continues. I mean, it cycles over and over and over and over, but we're just doing one cycle. Then we're going to look at our equation again, and we're going to find what the transformation is, and we're going to describe it. So in this case, our transformation is a vertical shift down 1, and you could also say there's a vertical stretch by 2 for the because the amplitude is 2, but we don't always say that part. So our next step then would be to change our amplitudes to go to 2. So instead of the amplitude of 1 for our parent, we're going to vertically stretch it, so the amplitude, the highest point is going to be at 2, and the lowest point is going to be at -2. And then from there, we're going to shift each point down 1 because of our midline has shifted our whole graph down 1. So each one of these points, I'm going to shift down 1, down 1, down 1, down 1, and down 1. So then my final one cycle is going to look like that last yellow graph. So now we're going to take it to the next step, and we're going to look at horizontal shifts left and right. So that was a review from last week of a vertical shift where we move down. And now we're going to look at what happens when we have a number inside the parentheses with the x. And this is the same concept as what we did with our quadratics, absolute values, all of our polynomials, anything inside the x, inside with the x, inside the parentheses with the x is going to be a a horizontal movement. So for the most part, we're just going to look at horizontal shifts left and right, and not necessarily focus on horizontal shrinks or stretches, although we did look at a little bit of that last week. Okay, so I'm going to start with amplitude. I'm changing up my colors. So my amplitude is whatever number is here multiplied in front of our cosine, which in this case is 1. So our amplitude is not going to change from our parent. And then our period is our 2 pi divided by whatever number is multiplied by the x, or in front here of the parentheses. In that case, it's a 1. So again, our cycle is going to end at 2 pi. So that's a horizontal distance of 1 cycle. Then we've got in this case, a horizontal shift. And so since we are adding pi, that's going to shift to the left. Remember how we always do the opposite? You're rebelling against your parents or whoever you live with. So we are going left pi for our horizontal shift. And then we've got our midline as always. We want to look at that. The midline is whatever number is added or subtracted out here in the end. In this case, there is no number that we see, so we know our midline's not going to shift. It's going to stay at the x-axis. Okay, so we start with graphing our parent, and this is a cosine function. So again, we're going to start at 1, 0, go down to 0, down to -1, back to 0, and then back up to 1. So this is our parent. That's one cycle. It continues, remember. This time our amplitude is not going to change, and our period length is not going to change, but we're going to shift each one of these points left pi. So I'm going to start here. First, if you notice your scale on the x-axis, it takes 4 spaces to get to pi. So each one of my points I'm going to shift left 4 spaces. So I guess that guy would be outside. So the one that's on the y-axis, the y-intercept, is going to shift off my graph. My point at pi over 2, 0 is going to shift 4 spaces, or a length of pi. The one at pi -1 is going to shift 4 spaces. And then 3 pi over 2, we're going to shift it 4 spaces. And then 2 pi, we're going to shift it 4 spaces. So this is what cosine of x plus pi looks like. Okay, you could pause the video right now and you could try the next example on your own using sine. Or you can follow along with me. So I'm going to start with the amplitude, looking at the amplitude, and notice how there's no different number in front of the sine. So our amplitude is going to stay at a high of 1 and a low of -1. Our period, again, no number that we can see multiplied in front of the parentheses. So our period is going to stay at 2 pi. The minus pi over 2 is going to now be a horizontal shift to the right. Pi over 2. Remember, it's the opposite of what it looks like. So if it's a minus, you're going to shift right. And then our midline is whatever number is added or subtracted at the end. And again, there is no number that we see, so our midline is going to stay at the x-axis. I am struggling at writing x-axis today. Okay, so we start with our parent. This time it's a sine, so we start 0, 0. Then we go up to 1, back to 0, down to -1, and then back to 0. So this is our sine parent, just like on the first page of our notes. Amplitude is not going to change. Our period length isn't going to change. That same distance from 0 to 2 pi will be one length of a cycle. But each time we're going to shift each point to the right, pi over 2. And if you notice on this graph, pi over 2 is 2 tick marks. So I'm going to shift each one of my points 2 tick marks to the right. And that's how I get my sine of x minus pi over 2. Okay, now we're going to look at what happens if we have a negative out in front. And just like with all of our other functions that we've studied this year, the negative in front is going to reflect it horizontally. Across the x-axis. Vertically, not horizontally. Across the x-axis. It's going to look a little bit different in some previous problems that we do, but to start with, it's just going to be a vertical reflection across the x-axis. So I'm going to start with my amplitude again, and this time some people might be tricked into thinking that the amplitude is a -1, but we have to remember that the amplitude is the absolute value of our a value. So actually the amplitude is still 1. Even though there's a negative in front, if we take the absolute value of -1, we still get 1. The period is the horizontal distance of one cycle length, and we're going to continue to have 2 pi as our length because there's a 1 multiplied by our x. Our transformation is just a reflection in the x-axis. There's nothing else going on in this equation from the parent. And so our midline is also going to stay at y equals 0, or the x-axis, because there is no number added or subtracted out at the end. I haven't been drawing in the midline because they're all been x-axes, but if you wanted to, you could draw that in like we did last week. Okay, I'm going to start again with my parent. The cosine starts up at 1, goes to 0, down to -1, back to 0, and back up to 1. So that's our parent cosine of x. To get the transformation, we're going to reflect each one of those points across the x-axis. So if it's the point is up here at 1, it's going to reflect down to -1. If it's on the midline, or in this case the x-axis, it stays where it is. This point down at pi -1 is going to reflect across the x-axis up to pi +1. The next point's on the midline, so it's going to stay there. And then our last point in this cycle is at 2 pi +1, and we're going to reflect it across the x-axis to 2 pi -1. And so here's our reflection of the cosine of x. It's so pretty. They're so pretty when they're together. It'd be great if you guys would take a minute and answer this summarizing question, just to kind of solidify in your brain what's going on here. What's different about the equations when we're looking for a horizontal translation compared to a vertical translation? So where in the equation are you going to find that difference? So take a minute, summarize, and then check back in. So hopefully you have a little bit more information written on yours, but in general, horizontal, you're looking inside the parentheses with the sine or the cosine, and then vertical, you're looking for outside the sine or cosine function. Okay, and we're going to continue to look at some more situations. These all have reflections, and then in addition, a reflection with a vertical transformation and or horizontal transformation. So we're going to go through the same process. The amplitude, looking for the number in front, multiplied in front. So this is a -1, so the amplitude is going to be +1. The period length is going to be 2 pi divided by the b value, and in this case our b value is still 1 because there's no number multiplied by the x other than 1. Our midline is whatever number is added or subtracted outside of the sine or cosine function, and so in this case our midline is at 2, so I'm going to go ahead and draw that line in. So I know where my graph is going to shift up to. And then the last thing is to look for the transformation. So we've got ourselves a reflection and a vertical transformation up to. So I'm going to write that down for my description. I'm going to have a reflection and then a vertical shift up to. Okay, so we start again with our parent, which is the sine. That starts at 0, 0, goes up to 1, back to 0, down to -1, and then back to 0. So there's my parent sine. It's not going to be stretched or shrunk or anything, but we are shifting up. Everything is going to be shifted up to the midline. So all those points that I just drew are going to be on the midline up here instead of on the x-axis. And then our last piece of this is the reflection. So if it's a point that's on the midline, we'll stay on the midline, but then our reflection is going to reflect across the midline. So I'm going to use red for my final. So stays on the midline. Otherwise, it reflects across the midline, each point. So this time, our negative sign of x plus 2 is going to be this red function. This whole guy right there. Okay, I'm just going to keep chugging right along. Amplitude for our negative cosine of x plus 2 pi is 1. Our period is 2 pi divided by b. In this case, there's no number other than 1 multiplied in front of the parentheses or in front of the x. So our period stays at 2 pi. Our midline is going to stay at the x-axis because there is no number added or subtracted at the end of our function. And we can see that we've got ourselves a reflection because of the negative in front. And then also we're going to be shifting horizontally, so a horizontal shift. And this is a plus pi over 2, so we know that means we're going to go left pi over 2. We're going to start with our parent. So the cosine starts up top at 1, then goes to 0, down to negative 1, back to 0, and then back up to 1. Our midline is staying at the x-axis, so that's not going to change. Amplitude's not changing, period's not changing. We're just going to shift each one of these points left pi over 2, and then we're reflecting it across the midline. So you should do your shifting left or right first, and then do your reflections last. So we'll shift each point left pi over 2. And if you notice on the scale on this, pi over 2 is two tick marks. So I'm going to take each one of my points and move it, shift it left 2 spaces. And then I'm going to reflect everything. So if it's on the midline, it stays on the midline. So those guys are stuck there. The other points that are not on the midline are going to reflect across the midline. Oh, too far. So then I've got my reflection. So my final function is going to be in red. And we're going to keep going. Look at another one. This one's the most fun of all of them because we have 3 things going on. We have a reflection, we have a shift to the right, and then we have a shift down. So way more exciting than the rest. We're going to start with our amplitude, which we again have amplitude of 1. These are kind of boring, huh? Our period, also boring, hasn't changed. It's just 2 pi. It's way more exciting when there's other numbers to deal with. Our midline this time did change because we are shifting down 2. So now our midline is going to be at negative 2 down here. And then last but not least, our transformation. So we've got ourselves a reflection, and that's going to reflect across the midline. We have a shift to a horizontal shift, right pi. Remember, if it's a plus, you're going to go left. If it's a minus, you go to the right. So it's the opposite of what you think. And then our last thing would be a vertical shift down 2. And that's, again, from our midline. Shows up on our midline as well. Okay, so we start with our parent. The sign, 0, 0, up to 1, back to 0, down to negative 1, back to 0. So there's our parent. When we have multiple things like this going on, we want to do our shifting left and right, up and down next. So we're going to take each point and move it right to pi. So that's 4 spaces on this graph. So there's all of our 5 points. Each one's been shifted right pi. And now we're going to shift down to get to our midline. So all the points that were on the x-axis should shift down to the midline. And then last but not least, we're going to reflect everything. So I use yellow this time. So if it's on the midline, stays there. If it's not, it's going to reflect across the midline. And by now, you've done probably enough graphs to feel like, oh, this is upside down when you reflect it. So then that's our final one cycle of our sinusoid negative sine of x minus pi minus 2. Yay! Okay, so make sure that you guys are practicing, please. This is new stuff for you, I know, so it's going to take practice to get used to it. Your homework assignment is down here at the bottom of the page, or you can find it on Big Ideas. This time, just so you know, the quiz is not going to be on Big Ideas. It will only be on the Google Classroom. So I'm going to write that down. And it'll be in the directions, of course, on the Google Classroom. It just there weren't good enough problems. So we're only going to look at your work on the paper that you graph. And remember, please use graph paper and or print out the graphs that are attached. If you notice on this assignment, I did a little bit more cutting and pasting and trying to put the graphs next to the problems that you're doing. And you didn't have to do 25 or 26 on this, but I did the cut and paste, so you can ignore 25 and 26. Just start with 27, 28. And then you've got graphs, and then there graphs for the 41, 42, and 45, and then there's one extra graph just in case you make a mistake. So those you can for sure check on Big Ideas. That's a good way to see if you're making any mistakes, and or you can watch some videos. Maybe they'll make more sense than I am. But then when you take your quiz, again, it's just going to be on the Google Classroom. Okay, so I hope you're all doing well. Please, please let me know if you need help. Not that many people are asking, and so that really worries me. Hopefully you guys are talking to each other at least, and just staying active with your brains, and we're almost done, so then you can take a break. But just finish strong. Miss you guys. Take care.